This is a quick podcast about the law of cosines. Hopefully you went through the exploration and saw how to derive the law of cosines. But even if you didn't understand that, you can still do problems using the law of cosines. So I'm going to do two problems. I've got the law of cosines written up here, and notice here's an important thing. It looks like the Pythagorean theorem, except then there's this extra stuff hanging off of it. And the one thing to really pay attention to is that the angle that you have as angle C over here is opposite the side that you have on this left-hand side of the law of cosines. And the sides, the A and the B on the right-hand side of this equation are the other sides. So this is a really straight application. Now, it's not going to always be sides A, B, and C. They could be any sides. But when we set this up, in this problem here, I'm going to solve for side P. And then I also want to solve for the angles, but we can do that with the law of sines as well. So we're going to use both of these. So here's how I'm going to set this up. P squared equals, well, I'm going to have cosine of P, which is cosine of 48 degrees over on this side. And the other things I'm going to fill in here are 8 squared plus 15 squared minus 2 times 8 times 15. Now when you do these problems, we don't really care what 8 squared and 15 squared and the cosine of 48. We're not really interested in those things. So when you do this problem, you go to once you have it written out like that, you just plug that into your calculator. So I'll do that over here. 8 squared. See if I can get my calculator to work here. 8 squared plus 15 squared minus 2 times 8 times 15 cosine 48. Make sure that you're in the correct mode, which I am. Press enter. Now that is P squared. So I want to take second square root of second answer. I want that thing that I had before, 128.41, and take the square root of it, and I get 11.33. I'm going to store this in alpha P because it is side P. Okay, and that's what I'm going to write down. Side P is equal to 11.33. Now you could write down the 128.41. I'm going to change this. I change my calculator here so it's not cutting off my decimals. There we go. Anyhow, that's what I was. So you could round that to anything you want to, but I now have that stored in alpha P. Now I can use the law of I didn't like the looks of that P. So now you can use the law of sines to solve for other angles. Here's a big note. Do not try to use the law of sines when you're trying to find an angle that might be obtuse. So if you look at this triangle, Q might be obtuse. I don't know if it is or not, but it's the only angle in this triangle that could be obtuse because it's across from the biggest side. So I think I'm going to solve for angle R now. So the sine of R divided by 8 is equal to the sine of 48 divided by 11.33. And I do the sine of R is equal to 8 sine 48 divided by 11.33. R is equal to the inverse sine of that stuff, sine of 48 over 11.33. I'm going to use the stored value. So on my calculator, I'm going to put in inverse sine of 8 sine 48, close parentheses, close the other, no, don't close that parentheses, divided by alpha P. Close parentheses, enter. That is 31.6 degrees. So angle R Angle R is equal to 31.64 degrees, and angle Q then would be 180 minus, let's do the second answer here, minus the original 48. Enter, that is 100.3536. Angle Q, angle Q is equal to 180 minus 31.64 minus 48 equals 100.36 degrees. Now we could not have found this angle Q if we had tried to use the law of sines to find angle Q. It would have found the supplement of angle Q, and we don't want that. So that's just a rule that we want to follow. Do not use the law of sines to find an angle that might be obtuse, the biggest angle in the triangle. Okay, that's one application of the law of cosines, to find a missing side. When you have side angle side, this is a side angle side problem. Here is another application. Here's as if we have side, side, side. We still set up the law of sines. Now I'm going to actually solve for angle n right now. So I'm going to put 11 squared here. That means the cosine of n is going to go over here. And this is 8 squared plus 6 squared minus 2 times a times 8. Okay, now again, I don't care what 11 squared. I'm going to do a bunch of algebra to isolate cosine n. So that is going to be 11 squared minus 8 squared minus 6 squared is equal to negative 2 times 6 times 8. Don't even bother multiplying these things out because your calculator can do it better than you can. Then do 11 squared minus 8 squared minus 6 squared divided by negative 2 times 6 times 8 is equal to the cosine of n. And we want to take the inverse cosine of all that junk. Now, when you enter this in your calculator, be really careful. Here's what you have to do. 11 squared. Your calculator is going to provide that first parentheses, and then you have to put parentheses around the whole numerator, and then divided by, and then parentheses around the whole denominator. You can do it like this on your calculator. Close parentheses, that's going to equal n. So here's what it looks like on your calculator. Inverse cosine of parentheses 11 squared minus 8 squared minus 6 squared, close parentheses, divided by parentheses, negative 2 times 6 times 8, close parentheses, close parentheses. There might even be another parentheses, but it doesn't care. 102 degrees, 0.6, 102.6 degrees. Notice that the law of cosines did find me an obtuse angle. It can, but the law of sines cannot, our inverse sine cannot. So this is 102.6 degrees. And I could then find, using the law of sines, this one is 102.6 degrees. I could use the law of sines to find the other angles. But I'm not going to keep going here. I'm going to let you find those and do it yourself. So hope this helps. See you in class.